Okay, so today we're going to learn about the reciprocal parent function. And this is the equation 1 over x. This is a reciprocal function. 1 over x. So if I were to make a table, I'm going to plug in the x values -3, -2, -1, and -1/2. The reciprocal of -3 is -1/3. You just flip it. The reciprocal of -2 is -1/2. -1 is just -1. And if you flip -1/2, you get -2. That's why it's called the reciprocal function. Also look, if you have a x value of -3 and you plug it in right here, you get -1/3, which is what we have. So this is the reciprocal parent function. So those are negative values. Let's put some positive values in our table. If you plug in 0, you'll have 0 in the denominator, and that is not allowed. So 0 is undefined. Next, let's plug in a 1/2. The reciprocal of 1/2 is 2. The reciprocal of 1 is 1, and the reciprocal of 2 is 1/2. So go ahead and plot these points on your graph. A -3, -1/3, -3 and go down a little bit, -1/3, -2 and then -1/2, -1, -1, and -1/2 is at -2. So it's going to start sloping down. And then at 0, you have an asymptote. You're going to have both a vertical and a horizontal asymptote at 0. You're going to get very close to those lines but not touch it. And then the positive side, at 1/2, you're at 2. Then you have the point 1, 1, and at 2, you're at 1/2. All right, so let's talk about the domain and the range. So for domain, we're looking at the left side and then the right side. So on the left side, it's pointing to -infinity. It will keep going this way. And if you follow your graph, it gets very close to this asymptote, which is at 0. It gets very close, but it doesn't touch it. Then your graph continues on this side. It starts at the asymptote, and it goes to the right. So that's 0 to infinity. So basically, x can be everything except for 0. Your range, the very bottom, it's pointing down to -infinity. And if you follow the graph up, it comes up here to the asymptote, which is at 0. And then it continues on this side. It starts down here at the asymptote, and it goes up. So 0 to infinity. You could also say y is not equal to 0. It can be anything but 0. Your vertical asymptote. This is your vertical asymptote. That crosses the x-axis at 0. So that's x equals 0. Your horizontal asymptote, this way, that crosses the y-axis at 0. So we'll say y equals 0. All right, so you guys should have already filled out this part. This is a review. We do this every unit. So H, what did you guys put for H? H is the good horizontal shift. And if you have a minus sign right here, where would it go if you have a minus?
To the right.
Yep, to the right. And if this was a plus sign, where is it going?
To the left.
To the left. Now if you have a plus K, where is it going? Up. And a minus K, where is it going?
Down.
Down. Perfect. And K is the vertical shift. Now if your A is negative, that means you are going to reflect across the x-axis. And if the absolute value of A, think of it as a positive number, ignore the negative. If the absolute value of A is greater than 1, this represents a vertical stretch. Thank you. And what if it's between 0 and 1? Yep, compression or compress. Okay, so your vertical asymptote, it will always be written as x equals, and it's always going to be the h value. Your horizontal asymptote is always going to be y equals the k value. And we'll do an example. So the transformations that happened here, this x plus 4 means it went to the left 4, and this minus 7 means it went down 7. So if I sketch my asymptotes, I'll have a vertical asymptote right here, going through the x-axis at -4. And 1, 2, 3, 4, 5, 6, 7. Right here at -7 is my horizontal asymptote. Okay, now normally you have a point here and here, right? One little space away. However, you vertically stretched by 2. So instead of being here, you're going to be 2 spaces away from that asymptote. You'll be 2 spaces away from that asymptote. And then you can just sketch the graph. As you move this way, you're going to get close to the asymptote, and as you move this way, get closer to that asymptote that you drew. Okay? Now, if you want to find those points a different way, my recommendation to you is choose x values that are close to your asymptote. So your asymptote is at x equals -4. Choose right here and right here, -5 and -3. So if I plug in -3 and -5, let's see what happens. So if I plug in a -3 here, I'll get 2 over -3 plus 4 is 1, and 2 minus 7 is -5. So notice, there is my point at -3, -5. Okay? Now plug in a -5. So if I plug in a -5 right here, plug in a -5, you'll get 2 over -1. So this becomes -2 minus 7, which is -9. And that's this point down here, -5, -9. And of course, if you want more points, just plug in more values. You can plug in a -2, you can plug in a -6, plug in all kinds of values and get more points. Any questions on this part, on how to graph? Okay, great. All right, now let's answer questions about the domain and the range. The domain, pointing to the left side right here, this goes forever to the left, so this is -infinity. And then follow your line. It gets very close to the asymptote. Your asymptote is at -4. Okay, next, it continues on this side. So you start very close to this asymptote at -4, and you go to the right. So this is -4 to infinity. So that's your domain. Your range, this part is pointing down to -infinity. Follow the line, and it gets close to this asymptote. The asymptote is at -7 because it went down 7. Then continuing at -7, it goes up. So this is -7 to infinity. So guys, notice, this is always, these numbers should always match. This went left 4, so you should have -4s here. This went down 7, so you should have -7s here, okay? Your vertical asymptote is x equals -4. That's where your vertical asymptote is. And your horizontal asymptote is y equals -7. Yes?
I thought whenever it goes from -infinity to -4, isn't the thing supposed to be like a rectangle instead of rounded?
Oh, you mean like a bracket?
Yeah.
You can't have a bracket here because you have an asymptote. You don't equal asymptotes. You can never be on the line. So these will always be parentheses. No bracket. Never have a bracket on an asymptote. Great question. Okay, so guys, this went right 5 and up 3. So right 5, 1, 2, 3, 4, 5. Here's my vertical asymptote. So this is the line you cannot touch. You'll get close to it, but you will not touch it. And then it went up 3. Here's my horizontal asymptote. Now, normally, your graph, you have points here and here, and it goes like this. However, you are reflecting, so it's not there anymore. your graph is actually right here. It reflected across the x-axis. So this part came down here. It's reflected. All right, I'm gonna let you guys answer the question for domain and range. So your asymptote's at 5, so I'll pick 4 and 6. So if you plug in a 4 right here, you get -1 over a -1. So that becomes 4. And that's why you have the point right here, 4, 4. And then if you plug in a 6, you get -1 over 6 minus 5 is 1 plus 3. So -1 plus 3 is 2, which is why you have this point right here, 6, 2. And you just draw your asymptotes, or get close to the asymptote. Okay, if you would like to graph the x-intercept, that means you need to plug in 0 for y. Because notice, whenever you have an x-intercept, which is along the x-axis, all those y values are 0. So you know whenever you have an x-intercept, that y value is going to be 0. So that means I'm going to plug in a 0 right here. So now you solve. I'm going to subtract 3 from both sides. 0 minus 3 is -3. And you have this. Next, you can multiply both sides by x minus 5, and those will cancel. And multiply this side by x minus 5. So this will be -3x plus 15 equals -1. And now we're solving for x. So move this 15 to the other side, making it a -15. So you get -3x is equal to -16. Then divide both sides by -3. So x equals, so a negative over negative is positive. So it'll be right where I have it, positive 5.33. Okay, so that's how you find the x-intercept. So how you find the y-intercept, you plug in 0 for x. So you have y equals, you plug in a 0 here, so you get -1 over -5 plus 3. So this is equal to 1/5 plus 3. So you get and 1/5 as a decimal is 0.2. So you get 3.2. And that is about right here. So if you keep my graph going, it'll go through that y-intercept. So that's how you find the x-intercepts and the y-intercepts.